All right, so a review of inequalities today, because we're going to review interval notation, which is what we need to do domain and range for tomorrow and Wednesday. Thursday is gonna be finishing up the notes and work practice day. And then Friday, you'll have the skill quiz over domain and, is it Friday? Friday or Monday, you'll have the skills quiz over domain and range. So Thursday and Friday are kind of going to be like work days, so that any retakes or whatever, you'll have some time in class to get them caught up in there too. Because we only have 2 more sections of this unit, and we'll be into unit tests for this unit. So if there's any retakes from this unit you want to get caught up, think about that stuff too. Cool? You alive, Jordan? Are you awake? I'm not. I didn't sleep very well last night, so I'm a little groggy today, so you'll have to bear with me if I say one thing and write another. Been known to do that before, huh? All right, so review of inequality. So let's start off with some vocab. What is an inequality? Anything you know about an inequality. Go back in your memory banks and tell me anything. Anything? Okay, in the real world, what is an inequality? When it comes to like people and things like that, what does it mean to be an inequality? Okay, so in the real world, women in the workforce make 86 cents to every dollar that a guy makes. So if you have one guy and let's say as a manager and he makes $1 an hour, if a woman holds the same position, typically she makes 76 cents an hour. Okay, that's true statistics. That's an inequality. They're 2 people doing the exact same job, right? One is not equal to the other. Would you agree with that? All right, math, same thing. An inequality is an equation that shows 2 things are not equal. Okay? How about a constant? What's a constant? In the real world, not even in math talk. When you think of the word constant, what does it mean to you?
Stays the same.
Stays the same. So same thing for math. It is a fixed value. It stays the same. Okay? So basically what that is it's the number. There's no variable, because a variable would make it change. It's just a number by itself. So, I don't know. Mitchell, give me a number.
6.
All right, 6. That's a constant. Okay. What about infinity? How do you define infinity? That one's a hard one to come up with the words on. Goes on forever. Yeah, it does. What did Buzz Lightyear mean when he said to infinity and beyond? Because it keeps going no matter what. It doesn't ever end because you can get there, but there's always more out there past it, okay? And so the math definition says it's without bounds. Okay? And in the math speak, okay, if you have a set of integers, what's a set of integers? What are your integers? What are whole numbers? What? What's a whole number?
A number that can be divided by itself.
Yeah. So like you have your whole numbers, which would be like 1, 2, and 3, right? It can be divided by itself. But they're only positive. Your integers is the positive and negative whole numbers. Okay? And it's a very specific set. Now that set's going to keep going on. It's going to go to infinity because I could say 1,254,000, and then my next number would be that I'm counting would be 1,254,001, but it is countable. Okay. Whereas the infinity set, because it goes on forever and it has all your fractions, we really don't know what number is between 1/8 and, like 1 over 0.08, I mean, it gets so small, it just keeps going on. So the set is not countable. All right, interval notation. Go back in your memory banks a couple years ago. And you did some interval notation. And it's just special language or writing, okay? It is, so notation, which means writing, of a set where your endpoints, I should say where the numbers, my bad, are the endpoints. Good? Alrighty, so when we graph inequalities, if the inequality is greater than or less than, what kind of dot do we show on the graph? Do we remember this? And I see that, I should do this. An open dot. So if, for example, I have x is greater than 6, if this is 6, I'd have an open dot, and it's all the numbers greater than 6, so it's going to infinity, and it would look like that. Does that ring bells? Awesome. Okay, if I used an open dot when it was greater than or less than, what do I use? What kind of dot do I use when it is greater than or equal to or less than or equal to? Closed. See, and I'll come back to you right away. Okay, so if x is greater than or equal to 6, then I have the closed dot, and it's going to infinity. Okay. All right, interval notation. Okay. There's some rules when you use interval notation. Okay? When your inequality is greater than or less than, you're going to use parentheses on the constant or number. Okay? That means that the constant is not included in the solution. Okay? If the inequality is greater than or equal to or less than or equal to, then you use brackets on your number. That means it is included in the solution. And I kind of think of the fact that, like, when, let's say my number is 3, when I put a bracket around it, it kind of wraps around the number to include it, whereas when I just have the brackets, it's just, or a parenthesis, it's just kind of finishing it. All right, that's how I keep it straight in my mind. All right, when your interval goes to negative infinity or infinity, we always use parentheses. Because if you think about it, that number's not going to be really included because it's going to keep going on and on and on. And our interval notation is always going to be written from least to greatest, because you're reading the graph and you're reading the interval notation from left to right. Is this ringing bells? Do you guys remember the interval notation? Yes, no, kind of, maybe. Okay. All right, so let's graph on the number line our inequality, and then we're going to write the inequality using interval notation. All right, so x is greater than or less, greater than or equal to 4. So am I going to have a closed dot or open dot? Closed dot on 4 because it includes it. Okay, and if my x is on the left, then I can go in the direction of my arrow. So my graph's going to look like that. Okay. So now, when you're writing your interval notation, you look at what's from least to greatest. What's my first endpoint? A 4. And are we including the 4? Yes, because it's a closed dot, so that means I put a bracket. Then I put the parentheses to separate. What's my end point on the grades? Infinity. It keeps going on forever, and so I use a parenthesis. Okay, good so far? All right, let's graph B. X is less than 5, so I'm at 5. Open or closed? Huh? Open or closed? Open, perfect. X is on the left, so I'm going to follow my arrow. Okay. Now, what's my end point, my lowest end point? If I'm going past that graph, because you can always think of negative infinity and infinity on both ends. So if I'm going past that graph, it's going to be negative infinity. And then what's the right end point going to be? 5. Right? Okay, now, am I going to use a parenthesis or a bracket? What'd you say? I can't hear. Parenthesis if it's not included. Okay? Good so far? All right. Then, if you have your inequality where it's written in the other way, I personally rewrite it. Otherwise, I get confused. I rewrite it so that, and sometimes it helps me to say it out loud, So I read it kind of like right to left. X is greater than -4. Otherwise, you're just kind of, think of it as a rotating door where everything just kind of flips around, all right? Because then I don't have to think about which way my arrow is going. My X is on the left-hand side. That means my arrow is going in the direction of the inequality. So if X is greater than -4, I'm going to have an open dot at -4. And I'm going along. So what's my first endpoint going to be? -4. Am I going to have parenthesis or bracket? Parenthesis, awesome. What's my left endpoint or right endpoint? Where am I going to? Infinity, which means I have to use a parenthesis. Good? Alrighty, so next one. I'm going to rewrite it. So I flip everything around. X is less than or equal to 6. Which means I'm going to have open or closed dot. Closed at 6. Going in the direction of my arrow or inequality. So what's my left endpoint? My least endpoint? What do you think? If I keep going, where am I going to? A negative infinity. And my greatest endpoint would be 6, but I'm using a bracket because it includes it. Good? Yay? All right, now let's take a graph and write the inequality in interval notation. All right? So I have closed dot, and I'm going this way, so it means that X is less than or equal to, and my number is 5. Oops. Helps if I have it. Agreed? Now, let's just take a look at our graph. What's my, same thing, what's my least endpoint? Negative infinity. And I'm going to my greatest endpoint, which is a 5. It's included. Good? All right. I have open dot, so that means that X is just greater than -1. It also means I'm going to use a parenthesis. What's my least? -1. I hear you whispering. What's my greatest? Infinity. Perfect. All right. Backside. Compound inequalities. Okay? That's where we put two inequalities together. You used to we talked about them, I think, in Algebra 1, and there were some ands, and then there were some ors. Okay, we're only going to use the ands for this particular one. Okay, now what I do is it's basically saying -3 is less than or equal to x, which is less than or equal to 5. And we need to graph both. What I do is I take and split them apart. So if I flip this, I get x is greater than or equal to -3. Easy enough to graph. I have a closed dot, and it's greater than, so it's going to infinity. Okay? And then I graph the other side. X is less than or equal to 5. Again, I have a closed dot. This time it's less than, so it's going to that part of infinity. Everybody with me? The solution set has to be for both. That means that my solution set is only going to be through this part where we have basically, and I did it without thinking about it, paste their colors. Okay, it has to be for both. All right, so that means my interval notation is going to be just where both are included. So my least solution set number is -3, and it's included, so I'm going to use a bracket. And then my greatest endpoint is 5. It's also included, so I use a bracket. Good? All right, let's do another one. So left side's going to be really x is greater than or equal to -1. So I have a closed dot, and it's going to infinity. And then I have that x is less than 10, but it's not included. So my solution set's just going to be this portion. And so my least endpoint is -1. It's included, so it's a bracket. My greatest endpoint is 10, but it's not included, so it's a parenthesis. Good? Feeling okay about these? All right, so x is greater than -6, but it's less than 4. And so I'm going to have -6, 4, and parentheses. Have you noticed a pattern between the notation here and your interval notation, your inequality and interval? Our least, our greatest. Our least, our greatest. Our least, our greatest. Okay? So without graphing, what's my least going to be? -7. And is it included? Is it a parenthesis or bracket? Parentheses. And what's my greatest endpoint going to be? 3. And is it included? So I need a bracket. Good? Okay, how about from infinity to infinity? That's the set of all reals, but basically, you just write it as same way, -infinity to infinity. Okay? So, let's look at the very first one, which is basically the same thing. This is where they just show the specific solution set. It's kind of like where I highlighted in pink up here. So I have from -2 to 7. So my interval notation is going to be from -2 to 7 with the parenthesis. Good. What's the last one going to be? It keeps going both ways forever. So that one's just -infinity to infinity. So do we feel okay about these so far? What's C going to be? 0 brackets, 0, 3, perfect. Awesome.